In this video, we will learn how to solve quadratic inequalities. Before starting our today's topic, let us quickly go through an important point, and that is, if we multiply or divide an inequality by a negative number, the sign of inequality must be reversed. For example, if we are given an inequality 11 minus 2x is greater than 5 and we are asked to solve this one, we will get minus 2x is greater than 5 minus 11, or minus 2x is greater than minus 6. Now we have to divide both sides of this inequality by negative 2 in order to get the value of x. So you will get x, and here we will get 3. As we have divided both sides of this inequality by a negative number, then the sign of inequality will be changed. This is a very important point, and we have to always consider this while solving our inequalities as required. Quadratic inequalities can be solved by sketching a graph of the given quadratic function and then considering when the graph is above or below the x-axis. In order to sketch the graph of a quadratic function, we need, number 1, to identify which way up the graph is. Which way up the graph is. It means that the orientation of the curve, whether the curve has a minimum point at its vertex or the curve has a maximum point at its vertex. And this can be easily worked out by looking into the sign of coefficient of x square in the quadratic function, which is normally represented by a, because general form of a quadratic function is ax square plus bx plus c is equal to 0. So looking into the sign of a, if a is greater than 0, then the curve has a minimum point at its vertex, and if a is less than 0, then the curve has a maximum point at its vertex. Secondly, we need to know the values of x-intercepts. Values of x-intercepts are required in order to solve the quadratic inequality. We don't need to find the value of y-intercept or the coordinates of vertex in order to solve the quadratic inequality. We just need to know the orientation of its graph and the values of x-intercepts to sketch it and then to solve it. Let us try to further understand it with the help of an example. Solve x square minus 5x minus 14 is greater than 0. We can see that the coefficient of x square is positive 1. Therefore, the shape of the curve will be such that it has a minimum point at its vertex. In order to get the values of x-intercepts, we can put y is equal to 0. Therefore, our inequality will become x square minus 5x minus 14 is equal to 0. We change this inequality into an equation just to work out the values of x-intercepts. So solving this one, we will get the factors x plus 2 into x minus 7 is equal to 0, which gives us x is equal to minus 2 or x is equal to 7. Now these are the values of x-intercepts. Therefore, this is the orientation of the shape and these are the values of x-intercept. We can now sketch the graph. We have minus 2 and 7. These are the points, and then this is the sketch of this curve. These points are known as critical points. So 7 is a critical point and minus 2 is also a critical point. In order to solve the inequality, in order to work out the solution set of this inequality, let us consider again the inequality for x square minus 5x minus 14 is greater than 0. It means that we need the values of x for which curve is greater than 0 or curve is positive, or we can also say that the curve is above x-axis. So this is very important to understand, because drawing the curve or sketching the curve is not an issue. Getting your answer from that curve is really important. So from the curve, it said that we need the values of x for which the curve is positive or for which the curve is above the x-axis. Let us try to explore for a couple of points. Let's say we have -3, and if we get the relevant y value, you can see that this will be positive. Similarly, if we take another value here, say 8, so again the curve is above the x-axis. This point is above x-axis on the curve. On the other hand, if we take a point, say for example on the curve, if we take a point here, or we take a point on the curve here, let's say this is 3. For this point, you will see that the y value of the curve is negative, or the curve is below the x-axis. So this point is not our required solution. Clearly, all the points which are either smaller than -2 or which are greater than 7 gives us our required solution. Therefore, in this case, our solution set is x is less than -2 or x is greater than 7, because all these points which are less than -2 or which are greater than +7, the curve is above the x-axis. Let's have a look into another example. In this example, we have to work out the solution set of the inequality 2x square plus 3x minus 27 is less than or equal to 0. So first of all, look into the coefficient of x square. It is positive, therefore the orientation of the curve will be such that it has a minimum point at its vertex. Secondly, we need to work out the values of x-intercepts, and for this one we will use y is equal to 0. So 2x square plus 3x minus 27 is equal to 0. Solving this one, we will get 2x plus 9 into x minus 3 is equal to 0, which gives us x is equal to minus 4.5 or x is equal to positive 3. So these are the values of x-intercepts, also known as critical values. We can now sketch the curve for the given function, and let's say this is minus 4.5 and here we have positive 3, and that is the sketch of this curve. After sketching the curve, again look into the quadratic function, which is 2x square plus 3x minus 27 is less than or equal to 0. It means that our solution set includes the values of x for which y is less than or equal to 0. Or we can also say that for which the curve is below the x-axis. Okay, so let us analyze the points here. This is minus 4.5 and here we have positive 3. If we take a point here, say for example x is equal to 2, and let's say what we get for y coordinates here, clearly y is negative and the curve is below x-axis for x is equal to 2. On the other hand, if we take a point say greater than 3, which is 4, for 4 we can see that the curve is above x-axis. So this is not our required point. Similarly, you can check some more points on the curve for different values of x. Say if we have -1, for -1 we can see that the curve is below x-axis. Similarly, if we take a value smaller than -4.5, let's say if we take -5.5, then you can see that the curve is above the x-axis. Analyzing the points, it is very clear to us that our solution set falls between -4.5 and +3, because any value between -4.5 and +3 gives us a value of y which is less than or equal to 0. Or for these values which are between -4.5 and +3, our curve is below x-axis. Therefore, our solution set is x is between 3 and -4.5. So that's all for today. See you in the next video. Take care.